So how's everyone doing?
Pretty good, pretty good.
So as you probably noticed, I graded the exams. Okay, a couple things. One, before I forget, Darian Solomon, please, you did this twice now. Do not leave the Zoom meeting until you finish submitting the exam. Rest of you followed procedures. Okay, so as a class, you guys are doing really well. The answer keys are up there. You can look at the answer key for the test. And if you have any questions, let me know. Now, I will include the 5%. Remember, class participation soon. Now, once I include it, and then all of a sudden you guys turn your video off or and stuff participating, you know, I can always take some of those points, change it again, just let you know, as far as the class participation goes. But there is no extra credit. I mean, you guys are doing really well, and those of you who aren't doing well, so trust me, I'm not going to be doing you any favors if I try to give you extra credit and help you pass. What are you going to do in Math 52? It's going to sound like a foreign language. So there's a few of you where your percentage is like less than 60%, like in the 50s or less than that, 40% average. For those, I would say you might want to consider dropping the class. You can get they could actually have a thing where you can get an excuse withdrawal again this semester. It's just, so yeah, 1 second, Rachel. Keep that in mind. And then also, so if you have any questions or concerns about your grade, feel free to stick around with me. But you know, your grades are updated. So if you have like a less than a 57, 58%, like it's not even 60%. Remember, keep in mind 70 is a C. So if your average is like more than 10% away from a 70, so like it's below 60, it doesn't look good. Again, feel free to stick around and talk to me after class. Rachel wants me to do question number 5. So yeah, let's go ahead and look at the exam 2 answer key here. So you go ahead and use the product rule. So this is first times the derivative of the second. So derivative of y squared is dy, 2y times dy dx, plus second times the derivative of the first. And then the derivative of tangent y is secant squared y times the derivative of y, which is dy over dx, equals 6. I'm not sure where you made your mistake. I don't remember. I graded these a while ago. So that's probably the toughest part, is getting that. Now, I noticed some people, I don't remember, when they write this out here, hold on. When I'm going to write this out over again, just to show you how some people do it. So some people write it out, okay, first times the derivative of the second plus second times the derivative of the first plus secant squared y dy over dx equals 6. So for some reason, this area right here on the first term, they put so much separation here. By the time they get to the next line, they think these two are 2 separate terms, but they're not. This is all one item. It's only a separate term when it's a plus sign or a minus sign. So you got to keep these together like I did over here. So then some people will move the x to the 4th to the other side, thinking it's its own term, and then from there everything goes wrong. A couple of people did that. Is that what you did? I don't remember.
Yeah, because in my answer almost looks like yours, except for on the top, I have minus x to the 4th. So I think that's what I did wrong. I separated them. And
okay.
I couldn't follow along when I looked at the answer key over the break, but I see it now. Thank you.
Okay, cool. Well, let me ask you a question on that real quick. Okay, all righty. So yeah, that's a common mistake. I've seen it some other people. Anyway, so yeah, if you have any other questions, let me know on the test. Let me see here. Let me go back and on the exam answer can look here. What else? What the heck is this little mark? Yeah. So anyway, or number 10. Yeah, so number 10, find the value C that's guaranteed if one were to apply the mean value theorem. So first you figure out what f of -1 is, which is, I plugged in -1 and I got f of -1 is -2. And f of 4 is 13. So then you find the slope by going 13 minus -2 over 4 minus -1. That's the y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's equals to 13 minus -2 over 4 minus -1, which is 15 over 5, which is 3. So that's the slope 3. That's the average you're going to change over the interval. So you have this parabola that's x squared minus 3, and you're going from -1 to 4. So that slope of that line is 3. So there has to be some x value in the interval from -1 to 4 where the slope of the tangent line is 3. So you take the derivative, which hopefully didn't cause too much trouble. The derivative of x squared minus 3 is 2x. Set it equal to 3 and solve. So x equals 3 halves. So x equals 3 halves is, so c equals 3 halves is where f prime of c equals 3. So, you know, I actually can draw a nice picture to show you what this means here. Can you guys just remember the question for me in case I forget, because I'm going to go to the graph paper. F of x equals x squared minus 3, okay? And then from -1 to 4. Okay. All right, so from -1 to 4, so we found out that the slope was 13 minus -2, right? Over 4 minus -1. So we got 15 over 5, which was 3. So So at x equals 4, the function value was 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 is over there. And at -1, it's 2. And then at 0, it's x squared minus 3. So 1, 2, 3. Okay. No, it's -2. At 2, it's 4 minus 1, which is 3. It's 6. All right, so this is what we're talking about here. This parabola here from -1 to 4. So what we did is we found out that the slope of the tangent line, that slope of the line that connects over the average rate of change over the interval is 3. So that slope right here, this 3, slope of that line is 3. What we did is when we found out that the derivative is 2x, when is that equal to 3? At x equals 3/2, and we said c equals 3/2, meaning at 3/2, which is 1.5 right here, its slope of the tangent line at when x is 1.5, at that value, the slope of the tangent line is the same as the average rate of change over the interval. That's what the mean value theorem says. Anyway, we're going to go ahead and start the next section here, 4.3. This dog won't stop barking. But my neighbors don't have dogs on this side. What? That's the title. What? You guys, give me 2 seconds. I don't know what the heck is going on because it's not my neighbor's dog. 1 second. My immediate neighbors don't have dogs, so something's going on out there. I'll be back in 2 minutes. All right, you guys, I'm back. Yeah, it's like the dog is way on the other side of the street. It's so loud. Must be a Chihuahua. Ooh, never get a Chihuahua. Okay. Those small dogs are like really aggressive. They actually think, no one ever told them that, like, you're a German Shepherd. You're a small dog, they can kick you 50 yards if they wanted to. All right, moving on. What was I going to do? Oh, yeah. So 4.3, how derivatives affect the shape of a graph. So let's go over a few things here. Remember, when you plug something into f of x, that tells you the y value. So now what we're going to do is, let's talk about the first derivative. If the first derivative is greater than 0, then f of x is increasing. If f prime of x is negative, less than 0, then f of x is decreasing. So what we're going to do with the first derivative test here is, the idea is, if we get a critical point and I want to determine if it's a local max or a local min, what I'm going to do is determine if, hold on, I didn't think about this, which I'm trying to, give me a second. I'm trying to figure out what's less confusing for me to teach you first. 1 second here. All right. We'll go ahead and we'll go with this. So what we're going to do is, you know how to get the critical point. So you're going to get a critical point. And what we're going to do is determine if you have a critical point. If we figure out that, hey, to the left of the point is decreasing, and we figure out to the right of the point is increasing, then that makes that point a relative min. This book will say local min, means the same thing. Some books will say relative. Some books will say local. I'm so used to saying relative but it means the same thing. They're interchangeable. Whereas if you have a critical point and to the left of it is increasing, it's an increasing function, and to the right of it is a decreasing function, then that makes it a relative max or local max. Oh my God, the dog finally stopped. Now, you could have a critical point. Oh, it's back again. So now you could have a point where it's increasing, but then it's still increasing to the right of it as well. So if it's increasing and then still increasing, then it's neither a max or a min, right? Because it's not the largest. I can't write here. 1 second. And then same thing if it's decreasing and then still decreasing. So let's do a problem. So what we're going to do when we're finding the relative extrema is I'm going to do a super easy one at first. So that's a 1. So what we're going to do is find the critical values first by taking the derivative, set the derivative equal to 0, and solve. And you get x equals 3. So now at x equals 3, that's a critical number, just like you did for the test, before the test. So what you want to do now is get the y value. How do I get the y value? By plugging it into f of x. So remember what I said here? When you plug into f of x, get the y value. So what is f of 3? So 3 squared minus 6 times 3 plus 1, 9 minus 18 plus 1. So you got negative 9 plus 1 is negative 8. So we have the point 3, negative 8. Now we want to determine if this is a local max or local min or neither. So what we're going to do is called, what I'm about to do is called the first derivative test. So I draw my number line, which represents the x-axis. So that's a 3. So this is, by the way, let me just do first derivative test. This is the technique that I'm using. So what I want to do is now the negative 8 here, you don't do anything with. It's for display purposes only. You're going to write, when you write your final answer, you're going to say 3 comma negative 8 is my local max or local min or whatever it ends up being. But you don't actually use the negative 8 for anything. But you need it to write your final answer. So what I'm going to do is pick a value to the left of 3 here. So pick a value to the left of 3, anything. It could be 2, 1, 0, I'll pick 0. And I'm going to plug it into the first derivative. Why do I plug it into the first derivative? Because the first derivative tells me if it's increasing or decreasing. So I'm going to plug in x equals 0, which is going to represent this region right here. So f prime of x equals, by the way, 2x minus 6. So if I plug in 0, 2 times 0 minus 6, which is negative 6. So it's decreasing. Again, I don't care. Now, why did I say it's decreasing, by the way? Because I got a negative first derivative. Remember, I don't care if my derivative is negative 6, negative 6 million, or negative 0.001. It's negative. That's all I care about. It means it's decreasing. And this little line that I draw here is just my way of knowing that it's decreasing. I'm not saying the graph is above the x-axis. This is just a little, this is not an official graph. It's just like my little chart, my little guide to tell me that it's decreasing in that region. Now I want to pick an x value that represents to the right of 3. So we'll pick 4. 2 times 4 minus 6. So that's 8 minus 6, which is 2. So it's positive 2. Again, I don't care if you got 2 million, 0.0001. As long as it's a positive number, means it's increasing. So it's decreasing to the left of 3. It's increasing to the right of 3. So therefore, at x equals 3, is that a relative min or a relative max?
Relative min?
Yes, relative or local min. And this is your final answer right here that I'm highlighting. And that's it. Now, this was an easy question in the sense that the problem, the original f of x that I gave you, well, you already knew that was hopefully from algebra that that's a parabola that opens upward, and it's going to have a relative min because it opens upward. But you're going to have tougher problems where you don't know how the graph necessarily looks like, so you have to trust your calculus. So you could have a graph that looks like, you know, that where you have a relative min here or a relative max there, multiple relatives mins, and so on. So we'll do another example. f of x equals x cubed minus 3x plus 6. Okay. So you're going to take the derivative. Set the derivative equal to 0 to find the critical values. So x equals plus or minus 1. Now, once you get plus or minus 1, you got negative 1 comma the y value, 1 comma the y value. Now, you still got to get the y values, but they're for display purposes only. You don't actually do anything with them. So let's go ahead and plug in negative 1 to the original function. F of negative 1 equals negative 1 to the third minus 3 times negative 1 plus 6. So you got negative 1 plus 3 plus 6. Negative 1 plus 3 is 2. Plus 6 is 8. Again, you need that for a complete answer, but you don't actually do anything with 8. Now let's do plug in 1. One minus 3 is negative 2, plus 6 is 4. Now, my final answer is going to be right here. I still have to come up, I can't guess. You can't just guess local max, local min, or neither. You have to, what we're going to do is called the first derivative test. So I draw my number line here. Here's negative 1, and here's 1. I'm going to get a representative value from each region, and that will determine if I'm going to test negative 1 first, right here. So give me a value to the left of negative 1. Negative 2, good. I'm going to plug it into the derivative. Now, why do I plug it into the derivative here? Because the derivative tells me if it's increasing or decreasing. That's the derivative right here that I'm plugging it into. So we got 3 times 4 is 12, minus 3 is 9. So it's a positive 9, so it's increasing. Let's plug in a value between negative 1 and 1. What's f prime of, let's pick 0. Three times 0 is 0, minus 3 is negative 3. So it's decreasing here. So at the point negative 1, 8 right here, is that a relative min or a max? Max, right? Because it goes up and then down. So that's a relative max. Now, don't all automatically assume the other one is going to be a minimum. It doesn't always alternate. Sometimes it could be neither. So let's pick a value to the right of 1. How about f prime of 2?
Professor?
Yeah.
So for f prime of minus 2, and you said it's increasing there. So if it's negative 2, 9, and it's going down to, or it goes, the next one is minus 8 or minus 1, 8, wouldn't it be decreasing? If it's
I don't understand your question. Say it again.
if it's going from 9 to 8 on the y value, wouldn't it be decreasing?
No, the 9 is the slope of the tangent line because that's the derivative is 9, not the y value. This is the y value being 8. This is the slope being 9.
Oh, okay, I got it. Thanks, Professor.
Where's your video?
Let me turn it on.
Oh, it's too late now. So that's 9 as well, so it's increasing. So what would make that? What would make that? What would that make the point 1,4? Relative min, right? Because notice here it's going up, then down. So this is the max right here. This is going down and then up, so that's a relative min. So the final answer right here is right here, what I'm boxing in red. Any questions? Now, what I just did right now is I also answered another question. I could have also asked you a similar question and you would have been able to answer it. If I asked you over which intervals is f of x increasing and over which intervals is f of x decreasing, we already have all the info. In fact, you didn't even have to get the y values to do that. So you would have done the same exact thing here, except you didn't need to get the y values. So the 8 and the 4 here, you didn't need to get. You'd still draw your number line and you still do the first derivative test. Looking at this little guide right here, the little number line that I drew, you can answer the question of over which intervals is it increasing and decreasing. So the answer would be, it's increasing on negative infinity to negative 1, because it's from all the way from here to here. And then from 1 to infinity, it's also increasing, union 1 to infinity. And you would say it's decreasing on the interval negative 1 to 1. So you know how to answer two different questions now. Well, don't worry, we're going to do more examples. So again, so look, you always think left to right. So from negative infinity to negative 1, it's increasing. From negative 1 to 1, it's decreasing. And then from 1 to infinity, it's increasing. Now, notice to represent this region, I picked negative 2. What if I picked negative 3 or negative 4 or negative 5 here? I would have got the same result. By same result, meaning I would have got a positive first derivative. Maybe not the number 9, but it would have been positive. If it's increasing here, it's going to be increasing here. Let me show you just with a dot here. If it's increasing here, it's increasing here, it's increasing there, it's increasing at all these locations. The only way it could go from increasing to decreasing if it hits a critical point, right? Because how can you go from a positive derivative to a negative derivative without first hitting a derivative of 0 or a derivative of undefined? So that's why at the very beginning, we figure out the critical numbers, where the derivative is 0 or does not exist. That means those are our borders, so to speak. When you know your borders, you know that that's the only possible place where a derivative can flip from a positive to a negative. So it's important to know where the borders are. Now I'm going to do another problem. I'm going to answer both questions on this next f of x. Not only are we going to answer over which intervals is f of x increasing or decreasing, but also the relative max and min as well. Okay, are you guys ready to move on? So just remember, When you plug something into f of x, that gives you the y value, the function value. When you plug something into the derivative, that tells you the slope of the tangent line, hence it tells you if it's increasing or decreasing. So we're going to answer two questions. The local max min and over which intervals is it increasing or decreasing. So f of x equals 12 plus 9x minus 3x squared minus x cubed. So what do? Take the derivative. What have we been doing the whole semester is taking derivatives, right? So 9 minus 6x minus 3x squared. Set. Now I notice sometimes students have trouble with the algebra. They know how to take the derivative, but then when they set it equal to 0 and try to solve, they mess up. So I'll tell you what I like to do here is let me rewrite it in order. Divide everything by -3. Now I can divide by -3 because there's no variable in there. So I'm not dividing, losing a 0 here. X squared plus 2x minus 3 equals 0. Factor plus 3 minus 1. So I get x equals -3, x equals 1. Now, if I just ask you the question, which intervals is it increasing at over which intervals is it decreasing, you don't need to get the y values. So when you draw your number line, here's -3 and here's 1. Make sure you have it, the -3 to the left of 1. So I'm going to tell you what the y values are. So when you plug in 1 into the original function, you're going to end up getting 17. So I plugged in 1 into the original f of x. So look up here. 12 plus 9 is 21, minus 3 is 18, minus 1 is 17. And then when you plug in -3, that's a little bit more work, but you end up getting -15. Now, we're going to figure out over which intervals is it increasing and decreasing, and also figure out if it's a relative max or min by doing the first derivative test. So the first derivative is 9 minus 6x minus 3x squared. So you can plug in -4 to represent the left side of the region. I would plug in 0 to represent the middle, and plug in 2 to represent the right side. Gumaris, I just saw you. Sorry, your laptop died. Maybe you should have charged it then before class.
Yeah, I had it plugged in because I got the notification and I thought it was fine. And then I looked and it wasn't plugged into the wall.
Any new location today, huh?
Yeah, finally back to normal.
Oh, wow.
Hmm.
All right, so when I plug in -4 here, you get 9 minus 6 times -4 minus 3 times -4 squared. Let's see here. 9 plus 24 is 33 minus 48 is -15. That's decreasing. That's my little symbol for decreasing on the number line. I'm not saying its graph is slanted like that. F prime of 0, 9 minus 6 times 0 minus 3 times 0 squared. That's just 9. It's increasing. And then f prime of 2, 9 minus 6 times 2 minus 3 times 2 squared. So 9 minus 12 is -3. Minus 12 is -15. All right. Again, don't always assume it alternates. Sometimes it could be increasing and then still increasing. So it would be neither. So notice here it's decreasing, then increasing. So that's at -3, that's a relative min. So it's -3, -15. So it's way down there below the x-axis. And then that's a relative max. So if I asked you the question of, is there find the relative min and max or relative extrema, you would do that. But if I asked you the question of over which intervals is it increasing, over which intervals is it decreasing, you would say decreasing on -infinity to -3, union 1 to infinity, and increasing on the interval -3 to 1. So that would be the other question that you can answer. Now on a test, usually I would make them completely two different questions and I would give you a different f of x for each one. And the reason why I like to do that is because let's say you made a mistake at the very beginning of the question and you just messed up on taking the derivative or you messed up on factoring and you didn't get the correct critical values. Well, then you would miss two questions. So I don't want one mistake to make you have two questions wrong. So I just make it a different f of x because I want to see if you know how to do different functions. All right, any questions on that? So given an f of x, you should be able to find the local max, min, using the first derivative test, and also be able to tell me over which intervals is the function increasing and over which intervals is it decreasing. Any questions on that? All right, so we're going to add to this. Let's take a break. And 13 minutes, we'll start at 4:15, okay? All right, let's go ahead and get started. So for a few of you, I put a message in the chat, on a direct message. I said if I can talk to you after class. You're not in trouble learning. I just want to talk to you, a few of you after class. I'll tell you what it's about. Don't worry. It's for the people that I wrote something already. Okay, so let's continue on. Going back. Oh, Madison, did you do anything interesting for spring break?
I did not. I slept in a lot. Nothing of value, no.
Nothing of value. Sleeping in is of value, believe it or not.
That's true. Also, it was very fun, so I feel like it balances out. How was your spring break? I realized we never asked you.
Well, I was grading exams the first half of it. So it was you guys's and other classes and other schools. So that was the first half. And then the second half, I went to Cabo for 3 days.
Oh, cool.
So
What part did you stay at?
Cabo San Lucas?
Yeah, what part? Like, there's like the marina, and then there's
Yeah, like near the marina. Yeah, I have a buddy who he has a timeshare. It's actually his brother. So I guess so he gets a really good deal. Basically, I don't know why it's called a timeshare, to be honest with you. But anyway, we kind of stayed with them. They were there a week, but I just joined them for 3 days.
nice.
Yeah, nothing of value. I just drinking. See, that's nothing of value. Okay, so okay, so here's the thing. Continuing on with the same section. Suppose you have a graph. So this point right here, that's a relative max, right? Because it's the maximum point overall. Sorry, it's the maximum point in its neighborhood. Like to the immediate left and immediate right of it, you can't find the point that's has a higher peak. And this would be a relative min, because there's the lowest point in its neighborhood. And then similarly, this would be a relative max. Now, just because you're a critical value doesn't necessarily mean you're a relative max or min. You could have a situation, oops, no, I was trying to wipe a hair off of this iPad and I scrolled it. So you could have a graph situation like this, like the y equals x cubed graph. You could have a situation where the graph is going up, it pretends like it's going to make a U-turn, but then it says, never mind, its derivative is 0 for a split second, and then it says, never mind, I'm going to keep going back up. So if you were to find the critical point, this would be a critical point, but neither a max or a min. So just because you're a critical point doesn't guarantee that you're a max or a min, but you have to be a critical point. But if you're a max or a min, you occur at a critical point. So now let's talk about something else. If you have a graph that looks like this, we call that concave up. It's like a cereal. The bowl is facing up, we say concave up. If you have a graph that looks like that, we call that concave down. Like serial is facing down. Now, a graph is not necessarily just concave up or concave down. It could be like concave up at some places, concave down at others. So, for example, let's say you have a graph looks like this. Well, it's concave down here, but then it's concave up here. The point, there's a point here where it's switches from being concave down to concave up. Let's say somewhere right there. That point where it switches from being concave down to concave up is called point inflection. So, more on one inflection a little bit later. So, I'm going to talk about now is the second derivative test. So here's the second derivative test. If, I forgot to mention this earlier. On a concave up, the second derivative is positive, and the concave down, the second derivative is negative. But what about that again? All right, second derivative. If the second derivative is positive, then f of x is concave up, and we have a relative min at the critical point. If the second derivative is negative, less than 0, then f of x is concave down, and we have a relative max at the critical point. So it's pretty logical. Just think about it. If you have something that's concave up, let's go back to the top one. Concave up, and you know it's a critical point, well, it's got to be a minimum. Whereas if it's concave down and it's a critical point, well, then it's got to be a maximum. So that's usually going with the second derivative test. And we're going to run through an example so you can see it. Now, what if the second derivative is 0? Well, if the scenario where the second derivative equals 0, then inconclusive. And you got to go back and use the first derivative test, the technique we used before the break. All right. I'm going to do an example now. So I'm going to actually do an example that we did before the break. But this time I'm going to do the second derivative test to see how the grade goes. Now, I always like to use most of the time the second derivative test if I'm not answering any other question. You just ask me to find the relative or local max min, and that's all I have to do. Now, a lot of times it'll be asked to find the local extrema or relative extrema. So the beginning part is the same. You take the derivative, set it equal to 0. So all of this is the same. You also get the y values. This is all the same. At -1, it's 8. At 1 was 4. So all of this is the same as before. I'm not doing anything different yet. By the way, did you guys want to quiz this Thursday?
No, but we can take the points if you don't mind.
I don't mind. So polite.
It would greatly be appreciated.
Ryan Choi, I've never heard it from you on the chat. Hold on one second. Okay, so who's we? What did I say? Oh, we. So anyway, so here's how it's different. So what I do in blue, it's different. So instead of me drawing a number line and going like that, you just test the value itself. You take the second derivative, which is the derivative of the derivative. In this case, it's 6x. And you plug in that value itself into the second derivative, the x value. Everything is done with the x value. The y value is the 8 and the 4 there are just there for display purposes. You plug in -1. So 6 times -1, which is -6. It's a negative second derivative. So again, it doesn't matter if it's -6, -6 million, it's a negative second derivative. So it means it's concave down. When the second derivative is negative, it means it's concave down and you have a ceiling. So therefore you have a max at the second derivative. So this is a relative max. If you were to plug in 1 into the second derivative, you get 6 times 1, which is +6. If the second derivative is positive, it's concave up. That's my symbol for concave up. So we have a relative min because it says a floor here. And that's how you determine the local max min by doing the second derivative test. So negative second derivative means it's concave down. Positive second derivative, it's concave up. When something is concave down, it has this look. Means it's going to be a max. When it looks like this, concave up means it's going to be there's going to be a min. All right, so now what we're going to do is same function. You're going to answer another question. Find all points of inflection. And for short, I'm going to write POI for points of inflection, okay? And over which intervals is f of x concave up? And over which intervals is f of x concave down? How did you get the second derivative again? The derivative of the derivative is the second derivative. So this is the first derivative, 3x squared minus 3. If I take the derivative of that, it would be 6x. Does that make sense, Robert? All right. So I got to give you the problem here. Same function, f of x equals x cubed. Now, this is a relatively easy one, but I'm showing you the process. Yeah, all right. And the fact that I asked you the points of inflection and over which intervals is it concave up or down, they go hand in hand anyway. So when you're doing one, you're automatically kind of doing the other at the same time. So it's a good combination to ask both of those at the same time. Omar, I haven't heard from you today. Are you doing well?
Me or the other one?
Huh? Omar
Me or the other
Dejani.
Yes. I'm doing pretty
Omar
good,
Aguilar,
Professor.
I haven't heard from you either. I keep forgetting there's another Omar.
I just put it in the chat.
Okay, so here's how you do the problem. So this was the question, I'll do the problem blue. First of all, what point of inflection occurs when the second derivative is equal to 0? Did I go over that? Okay. Point of inflection where, so it's just, yeah, it's right here, see? Where f prime, double prime equals 0. There you go. So we're going to take the derivative. Then we're going to take the derivative again to get the second derivative. We're going to set it equal to 0. So x equals 0. Now, since I said the point of inflection, it's an xy value. So point of inflection is 0, comma, what's the y value? Well, you plug it back into the original to get the y value. So if you plug it back into the original, you get 6, right? 0, when you plug it back into right here. If you plug it into there, 0 minus 0 plus 6 is 6. Now, here's the thing. I put point of inflection as 0.6, but I'm not 100% yet. It's a possible point of inflection. It's not like a critical point where it doesn't have to be max min. For me to confirm that it's a point of inflection, I'll confirm it while answering the second part of the question, where it's concave up or not. Because for it to be a point of inflection, it has to switch concavity at x equals 0. So let me go ahead and check the concavity to the left of 0 and to the right of 0. And if the concavity switches, then yes, the point 0.06 is a point of inflection. But if it doesn't switch, it says, ah, never mind, then it's not a point of inflection. So so remember, the second derivative tells us if it's concave up or down. So I'm going to plug in -1 to represent the left side. So 6 times -1 is -6. It's negative, so it's concave down. So there you go. That's my little guide that says it's concave down. I'm not saying the graph necessarily looks like that. It's just concave down there. Let's pick a value to the right of 0. How about 1? 6 times 1 is 6, so it's +6, so it's concave up to the right. And if it's at 1, it's concave up. At 2, 3, 4, it would be concave up. The only way it could possibly go from concave up to concave down if it's a point of inflection. And I know at x equals 0 is my only possible point of inflection. So here we go. We're answering the question. Yes, that is a point of inflection because it does switch concavities. So yes, we confirmed that that's a point of inflection. I also can answer the other question. Concave up on the interval 0 to infinity and concave down on -infinity to 0. Oops, I'm running out of room there. All right. How did I get the second derivative again? Oh, no, you already asked. Okay. So, and that's the answer to this part. So, I threw a lot at you today, so I'm going to recap from the beginning and go over everything. As soon as you finish writing this. So here we go. Ready? If you plug something into f, that tells you the y value. If you were to plug something into the first derivative, that tells you if it's increasing or decreasing. If you were to plug something into f double prime, that tells you the concavity. So on Thursday, make sure you learn this because on Thursday you're gonna learn what the third, fourth, and fifth derivative tells you. I'm joking. I'm joking. To get the critical value, set f prime equal to 0 and solve. Of course, or when the first derivative is undefined. To get the point of inflection, set the second derivative equal to 0 and solve. So use this as a guide. So right there, whenever you get stuck, you're wondering, okay, what do I do? I'm trying to get the y value. Where do I plug it into? Well, into f. I'm trying to determine if it's increasing at this x value. Where do I plug it into? Well, f prime. All right. So here's what I need you to be able to do for today's lesson. I'm going to exit this screen for a second, so let me wait until you guys copy it down. So notice on the homework sheet for 4.3, there's not that many problems assigned. It's just a few problems, and I said plus additional problems. Here are your additional problems. You don't need to write it down. Just, I'm going to put this on Canvas. So I put these 4 questions, and these will be, and number 4 is a repeat of a homework problem, so you don't need to do it twice. But besides the homework questions, these 4 questions. So for each of these 4 questions, this is what you're going to do. Answer these questions here. A, find a relative, or it's called local in this book, max min. Part B, over which intervals is f of x increasing and over which intervals is f of x decreasing? And C, find all points of inflection and state over which intervals f of x is concave up and over which intervals is concave down. So see those A, B, C, you got to be able to do all 3 of those for each of those questions. And eventually for all 4 of these, I'm going to put an answer key up on Canvas where I'll show you how to do every single one of these 4. But right now, I'm not going to do any of these 4 because this is homework. I'm going to make up another function and we're going to do A, B, and C for it, okay? But a different f of x because these are your homework questions. And I'll put it on Canvas later today.
Are we turning this in, or is it just like all of our homework where we just do it?
Yeah, it's just for your practice so you learn.
Oh, okay, thank you.
All right, so. Oh, which one was A? A was local max min. B was intervals, okay. We're going to do that. All right. So for A and B, you still got to find the critical values. So do you guys want to try to do these yourself, as many of them as you can? First, for like another 5-10 minutes at least. So here's what you got to do. A, find the local or relative max min. Part B, over which intervals is it increasing or decreasing? And then C is find the point or points of inflection and where is it concave up or down. Do the best you can on this, and I'll go over in 5 minutes. Hey, random question. Do any of you know anyone that got COVID twice? Because they always say, oh, you're only immune for 3 months, then you can get it again. I just want to know if anyone knows a person in real life confirmed that got it a second time. Oh, Brian, you do? Well, speak up.
Yeah, my friend's dad got it twice. He got it, I think, like the 3rd month after he got it the first time.
Well, you're on mute.
My friend's dad got it twice.
How far apart were they?
3 months.
Is he sure that he got COVID both times? Like he tested positive both times?
Yeah, so he tested positive the first time, and then it like, you know, he got tested after to make sure he was like negative, and then he got it again.
Now, when he got, what was his symptoms like? Was it worse one time than the other, or is it about the same type of symptoms both times?
The first time he said it, you know, it lasted about like 2 weeks, and then the second time it put him in the hospital. But to be honest with you, full disclosure, I know he does have some health ailments, so that probably didn't help him very much.
Okay. So he had like underlying conditions.
Yeah, like I said, the first time didn't hit him that hard, but the second time it got him pretty bad. He ended up in the hospital, and actually my dad, I mean my friend's dad, his stepmom got really sick too. So yeah, I don't know. It's kind of just kind of odd. That's
And is he older though? Is he like over 60?
I think he's like mid 50s, right around there.
Oh, that's not that old. Rachel, what are you laughing about? Did I see you say something wrong?
You just said that like that wasn't that old, and I don't know. My parents are like in their mid 50s, 60s, and I don't know. I think they're old, so I thought that was funny.
So your definition of old changes when you get older. Like when I was in high school, let's say like when I was 15, 16 years old, you think of someone that's in their late 20s as old. And then when you get in your 20s, you know, you think of someone in their 30s as old, but it just changes.
Both my parents, well, my parents had me when they were around 40. So I always had like older parents, and I don't know, my parents have always been like older compared to other like students or like my friends, like their parents were always like way younger. So I just always associate my parents with being old.
Oh yeah, me too. My parents had me old when they were older, so they were older than like my classmates' parents, like on a back to school night or something.
Like my sister was born when my mom was like 22, and then my mom didn't have me until she was 36. So we have like a big age gap. So
same here. My mom had me when she was 42, so my mom's up there.
But Brian, he's okay now. So like you said, you put him in the hospital. Was he on the ventilator or what happened?
Yeah, he was a bigger guy, so he did lose like a lot of weight because of that. But he's doing fine. The stepmom didn't do so very well at all. Actually, she had some permanent damage from COVID. I know that her kidneys got like she had to go like on dialysis or whatever, and I think she had some damage to her lungs, but she had some like tissue damage from COVID. Even though his dad got it twice, I think he got it a little bit better than the stepmom.
So the stepmom, does she have underlying conditions as well?
I don't know about her. I just know that the first time they both got sick at the same time, obviously because they're together. He got it a second time, you know, during that, and she was in the hospital that whole time. So that's as much as I know about her. But for him, he got out of it. He did get a little bit of damage though from it.
All right, I was talking too much here. So 2 more minutes, and then we'll go over it. I know I didn't give you enough time. any announcements, any jokes or anything for the class?
No, we don't have any announcements for the week except that we're going to continue as per usual. And I think you fill up the jokes pretty well for the class.
Oh, thank you. That was a joke in itself. I wonder if that dog, that Chihuahua, well, I'm assuming it's a Chihuahua because high energy. Did the owners like not leave it water or something? I feel like I should do something.
Chihuahuas don't really count as dogs.
Oh. How about a mini dog? Cole, are you all done? Okay, let's go over this. I'll give you another, actually, 2 more minutes. So no quiz this Thursday, but make sure you attend because we got more good stuff. L'Hopital's rule and
I have a question.
yeah.
For when we're looking for the POI and we get our X, do we plug that into the first or second derivative?
What are you trying to get?
The point of inflection.
You're trying to get the Y value?
Yeah.
Okay, so let's see here.
Thank you.
I didn't have to look at it, just I was trying to hint to you where you go at home if I'm not there to help you. All right. Now we got time. 3 more minutes. So that 4th problem and the additional problems that I will post on Canvas is the same as one of your homework questions. So you don't need to do it twice. I mean, you're either it's either you do the one in the book number 13 or do the one that I gave you, either or. I just have it in my list of problems because no matter what book I end up using for a particular school, I'm going to start giving those 4 questions. It's just those are good questions. As far as I like their difficulty level. All right, let's go over this. So part A, I got to find the derivative. This is, so 3x squared minus 12x plus 9. Set it equal to 0. So I'm going to divide everything by 3. factor. So x equals 3, x equals 1. Now I got to get the corresponding y value. So if I plug in 1 into the original function, 1 minus 6 is negative 5, plus 9 is 4, plus 5 is 9. Did you guys get 9? 3. Oh, I use my calculator for that. 3 to the third minus 6 times 9 plus 9 times 3 plus. You guys get 5 or 3?
Yes.
All right. Now, what I'm going to do is I'm going to answer the second question at the same time. So that way, so that's why the only reason I'm doing the first derivative test. So that way I can do part B at the same time. All right, so let's plug in a value to the left of 1. How about 0 into the first derivative? So f prime of x is equal to 3x squared minus 12x plus 9. So 0 to represent the left side, you get 9, which is positive. So all I care about, this is my little symbol for positive. How about a number to the between 1 and 3? By the way, 1 and 3, luckily there's a nice whole number between 1 and 3. But if there wasn't, like let's say you had a number line that looked like this, then you have to go with a decimal. But right now we can pick 2. So 3 times 4 is 12, minus 24 is negative 12, plus 9 is negative 3. All right, it's negative. Now let's pick a value to the right of 3. How about 4? So 3 times 4, 3 times 16 is 48, minus 48 is 0, plus 9 is 9. All right, so it's increasing. All right, so that would make at x equals 1, if you notice here, since it goes up, then it goes down, that's a relative max. Whereas this one goes down and up, that's a relative min. So at x equals 1, that's a relative max. This is a relative min. But at the same time, I just answered the other question by looking at the little guide there on the right side. It's increasing on negative infinity to 1, union 3 to infinity. And it's decreasing on 1, 3. Looks very similar to the one that I did already. So that's part B right there. So I did A and B already. Still got to do part C, which is find the point of inflection and where's the concave up or down. Well, I got to find the point or possible point of inflection, I got to take the derivative again. So the second derivative is the derivative of the derivative. So what I'm doing here is I'm taking this, and I'm going to take the derivative of that. So it's 6x minus 12. Set it equal to 0. Solve for x equals 2. So yeah, to get the y value, you plug it into the original. Let's see here. 2 to the third is 8 minus 6 times 4, right? So 8 minus 24 plus 9 times 4, plus 18, plus 5. You guys get 7. So that's a possible point of inflection. Now I'm going to test to see where it's concave up or down, and at the same time, we'll answer if it's confirmed if it's a point of inflection or not. So f prime of 0, to check the left of 2, would be 6 times 0 minus 12, which is negative 12. So that's concave down. Let's pick to the right of 2. How about 3? 18 minus 12 is positive 6, so it's concave up. All right, so it does switch concavity. So therefore, let's answer the question. It's concave down on negative infinity to 2, concave up on 2 to infinity. And that's the answer for part C. So basically, that's what you're practicing in this section, these 3 types of questions. And by the way, for part A, I could have used the second derivative test, but since I knew I was going to answer part B anyway, I did the first derivative test. But be familiar with the second derivative test, because when you do word problems later on, it comes in really handy.
Professor, so on the A, you use the first derivative to plug in the x values that you got, right? The x1
Yeah.
and x3. Okay.
And by the way, the way you can tell when you look at your notes, because you see it 1 prime here, so you know it's the first derivative. So if you're trying to figure out where did I plug in 2 into? See the prime here? That means I plugged into the derivative. Whereas here, you see f double prime means I plugged it into the second derivative. So that's why you need to have proper notation, so when someone reading your work can tell where you plugged it into.
Thank you.
Which part of the screen do you guys need to see? Are you guys good right here, or? Okay. All right, so you got the 4.3 homework you can do. I'm going to post this on Canvas, but if you want to go ahead and screenshot it right now, since some of you might not want to wait until I post it, but this is going to be posted on Canvas. Or this is in addition, part of your 4.3 homework. So other than that, I'll see you Thursday.
Professor, can you go back to the notes very quick if you don't mind? I'm sorry.
Oh yeah, some of you stick around the ones that I said I want to chat with you on the text, on the chat. I said one.
Thank you.